Okay, we're going to be talking about scatter plots again. So it says over here, scatter plots are similar to line graphs in that each graph uses the horizontal x, that's the left and right, and the vertical y, that's the up and down, axis to plot data points. So if you see over here, it's kind of similar to what we've been working with line graphs, only it's not a perfect line. There's little dots all over the place. Scatterplots are most often used to show correlations. Another word for correlation is relationship among data. So the reason why we make these scatterplots is to see if two variables are related to each other. So here we see that there are a bunch of dots that are facing downward in a linear trend. So that means there is some type of relationship going on over here. And same with this second one, which is how study time affects grades, and then the last one, how shirts affect salary. So here's some vocab words that will be used often in this unit. We gotta know what a scatter plot is. Scatter plot shows a relationship between two sets of data based on the random data points. Correlation is the relationship between two variables. So if I say that the correlation is a strong correlation, it means that there is a strong relationship. So one directly affects the other. If it's weak, that relationship is not as strong, it's not as reliable. So one doesn't completely depend on the other one. Line of best fit is a line that best represents the data on the scatter plot. Positive correlation is the data displayed on the graph resembles a line rising from left to right. A negative correlation is when the line of best fit goes downwards and it's the data displayed on a graph that resembles a line falling from left to right. And no correlation is the data displayed on the graph neither resembles a line rising nor falling from left to right. So those are some vocab words that you should have some good idea of, because those words will be tossed around throughout this unit. So a correlation can be predicted without having to observe data in a table or graph, just by using our logic. So here are some examples. So your grade point average and the number of A's received. So your GPA, is there an effect of the GPA on the number of A's you receive? So if you have more numbers of A's, what would happen to your grade point average? Well, if you have more A's, your grade point average would go higher. So that would be a positive correlation, because number of A's goes up, GPA goes up. If both of them go up, that means it's positive. So that would be a positive correlation. And we can just do this logically by thinking. Now, let's look at time spent studying and the grade on your test. So assuming that you are using that time wisely and actually studying, if you study more, then your grade will be higher. So that would also be a positive correlation. Let's see. The size of the person and number of fingers he has. Well, what do you think? Is there a correlation? So if the size of a person is smaller, so let's say someone really short, do they have less fingers? Versus a person who's really tall, do they have more fingers? No, there really isn't a correlation between that, because everyone has 5 fingers. So that means that that would be none. None. Now, let's look at over here the weight and height of each member on a soccer team. So let's see, height and weight. So let's think about it. If my weight goes up, what would happen to my height? Well, it's assumed that as you get taller, you weigh more. So both of these are going up. So let's say my weight goes down. If I have a smaller weight, then my height would also be down. So it is a positive. So correlation can also be shown in scatterplot using graphs for visual references. So here we have examples of 2 positive correlations. Here we have an example of no correlation, because there's no way that you could draw some kind of line of best fit. We don't know. It could go up, it could go down, who knows? There's no correlation. here we have a negative correlation because the lines are trending downward along with this one. So now we have strong correlations versus weak correlation. So positive correlation is when both data sets are increasing together, just like how we said height and weight is a positive correlation. So a good way to see if a relationship is strong or weak, just look at the data points on here. So if you look on this line, the data points seem to be rather close to the line. If it's closer to the line, that means it's a strong relationship. Versus this one, if you see the data points are a little spread out from this line, that means it's a weak correlation. So here we see a weak correlation, that's a negative correlation because the data points are spread out, versus this one, which is much stronger because the data points are right next, pretty close by the line. So a negative correlation is as one data set increases, the other one decreases. So here we have an example. It says use the given data to make a scatter plot of the weight and height of each member on a soccer team. So we already kind of mentioned about the height and weight. We said it was a positive correlation. So now we're going to put these data points on the actual graph right here. So we have the first one, 63 and 125. My height is 63 and my weight is 125. So that'll be right here. Let's now look at 67 and 156. We have 67 and then 156. Probably somewhere around here in the middle of 150 and 160. Seems about right. Let's look at 69 inches in height and 175 pounds. 69 and 175. Right in between 170 and 180. And we have 68 and 135, 68 and 135. Right in between 130 and 140 is 135. Lastly, we have 62 and 120. 62 and 120 is right there. So if we see, we do have somewhat of a positive relationship. And now that we have this relationship, we're going to be making a line of best fit. So I would just make a line, something like this. Doesn't have to be exactly perfect, but I'm trying my best to make a line of best fit. So if we see over here, these lines are very close to these 4 data points, and then this little straggler over here would be considered our outlier because it doesn't really, it's the most farthest away from the line. So all the other 4 points do a pretty good job of being close to the line. So this is considered the outlier. So here we have a positive correlation because it's going up. And we do have a strong relationship, a strong correlation besides this little outlier over here. So maybe this person is just kind of really tall but very skinny. So kind of the oddball, but nonetheless it is a positive correlation.